Hi all. In this lecture we will talk about CCA 175 real-time exam scenario 16. Let's see the data description. All the order records are stored at user Spark dataset retail_db orders HDFS path. And we also have order schema here. So in orders data we have orders underscore ID, order underscore date, order underscore customer underscore ID, and order status. The output requirement says that find all fraud transactions per month. That is, order status must be equal to suspected fraud. Use PARQUET format for the output files and use SNAPPY compression. Place the result data in HDFS directory. Output should only contain order date and count, and use yyyy-MM format for the order date. Output should be sorted by order date in descending order. Now, in order to solve this problem statement, we should understand how to read CSV data as a data frame in Spark. Then, on top of that data, we have to apply a group by clause, because we have to identify the suspected fraud orders per date. Then we have to sort this data based on the column order date in descending order. So we should understand how to apply order by clause. Also, we should understand how to save data in HDFS using PARQUET file format and how to apply SNAPPY compression on top of the data. So let's go to the lab and see. So this is my Spark shell. Let's read the data. So I'm gonna say well orders is equal to spark.read.csv, and then I'll be providing the HDFS path. This is my HDFS path. Now I'll be providing the logical column names using 2df, and then I'll be providing the column names. Now we got the data frame orders. Let's see some of the data. So I'll say orders.show and give me 5 records. This is my orders data. On top of this data frame, we have to identify the fraud orders per date. If you see the column order underscore date, it's a timestamp. So we will be extracting the date portion from it. And we have to convert this date into yyyy and mm format. So let's do that. So let's register this data frame as a temp view. So for that, we'll say orders dot create or replace temp view, and let's provide it a name here, orders. So let's fire a SQL query on top of this view. So I'll be saying well result is equal to spark.sql, and I'll be writing a query here. My query is select. Now I have to substring the date, so I'll be saying substring, and I have to substring order underscore date column from 1 to 7. This will be my order underscore date, and then I have to select order status, and then I have to calculate the count, and let's give it a name CNT. I have to select these columns from the view that we have created just above, orders. So let's put a where clause here. We have to select the data where order status is equal to suspected fraud. This will be my where clause. Then I have to apply a group by clause here. So I'll have to do a group by order date and order status. So for that I'll say substring order underscore date, comma 1, comma 7, and the second column is order status. And then we have to apply order by. And my order by will be, so I have to sort this data based on order date in descending order. So I'll say order by order underscore date column in descending order. And this is my query. Now, finally, we have to save only 2 columns in HDFS. So we have to apply a select function here and we have to specify the column we are interested in. So I'm only interested in order underscore date and the second column is count, CNT. So we got a data frame. Let's see that. Result.show and give me 5 records. So this is my final output. So we can see that order underscore date is sorted in descending order and we have the count of suspected fraud orders based on the order date. Now finally I have to save this data back in HDFS in PARQUET file format and using SNAPPY compression. So let's do that. I'm going to say result.write, which returns a data frame writer. On top of that I'll say option, and my option is I have a compression SNAPPY. This is my compression dot PARQUET. And my output path is okay, so we are done. Let's validate. So just copy this path, go to the other shell that we have and we'll do HDFS DFS-ls and we'll provide the path. So we can clearly see that partition files, they have been created with extension .snappy.parquet. That means the data is in PARQUET file format with SNAPPY compression. So we are done. So in this lecture, we have learned how to read CSV data as a data frame in Spark. Then we have learned how to apply group by and order by clause on top of the data frame. And finally, we have saved the data frame as a PARQUET file in HDFS using SNAPPY compression. Thank you.